Okay, hello everyone, welcome to the OneClass channel. My name is Andrew, and we're currently doing Stat and Math at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the link in the description below. So now let's start our session. Okay, so the first question today is asking us how to write 50% as a fraction. Okay, so let's copy down the question first. As a fraction. Okay. Okay, so whenever we come across a question asking us to convert something in one unit into another, so in this case, it will be percent to fraction, right? Yeah. So we'll start from the definition of percent. So we just need to simply put the percent value as a numerator over 100 as a denominator, and that's exactly what I mean by percent. So let's say 15% is just equal to 15 over 100. So imagine we have a cake and we cut it to 100 pieces and we take 15 pieces out from it. So that's where we get 15 over 100. Yeah, but we're not done for the question yet, since we need to write it as the simplest form. So we need to divide both the numerator and the denominator by the greatest common factor. Okay, so let's write it down here. So divide both numerator and the denominator by their greatest common factor. Yep. So here we have 15 and 100. Okay. So thinking about their greatest common factor, it should be 5, because let's write down the factor for 15. So that's 1 times 15, and that's 3 times 5, and that's it, right? And we can check, can 15 divide by 100? The answer is no. And can 5 divide by 100? And the answer is yes, because 100 divided by 5 is equal to 20, right? So we have the greatest common factor, so GCF will be 5. Okay, so let's rewrite the question. So 15% is equal to 15 over 100, which is equal to 15 divided by 5 over 100 divided by 5, which is 15 divided by 5 is 3, and 100 divided by 5 is 20. Okay, and that should be our final answer. So now let's just write the conclusion. So therefore, $15 can be written as the fraction 3 over 20. Yep. So I think that's all we got for this question. Let's leave a comment there. Answer is correct. Oops. There is some technical issues. Just give me 1 second. Okay, we're good. So our next question is asking us, what are the Taylor series and maclaurin series polynomial formula? Okay, so first let's copy down the question. Oops. So Taylor series and maclaurin series. Okay. So first, let's talk about the maclaurin series. Okay. So maclaurin series. Okay. So first, let's copy down the formula. Should be fx is equal to the summation Sn start from 0 to infinity Fn 0 over n factorial times x minus 0 to the exponent of n, which is equal to f0 plus the derivative of f0 x plus, oops, this should be as a numerator, f to the second derivative 0 over 2 factorial x squared plus x to the third derivative 0 3 factorial times x to the exponent of 3. Okay, yeah, and the process of expanding using maclaurin series is the same as Taylor series, which we will talk about later, and except for all derivatives are evaluated at a value of 0. Yep. So as you can see here, it's 0, 0, 0, and 0. Okay. Okay. Okay, so now let's talk about the Taylor series. Let's use another color. So this is given by fx is equal to summation as and start from 0 to infinity fn a over n factorial times x minus a to the exponent of n, which is equal to fa times f the derivative of fa x minus a plus second derivative of fa over 2 factorial times x minus a squared plus f to the third derivative a 3 factorial x minus a to the exponent of 3. Yep. Yeah, so if we're looking at the expansion, we see our first term is a function as a point A. So that is the, let's use another color. So function at point A. Okay, and the second term is the first derivative of the function at point A and multiplied by x minus a. And then the third term follows the same pattern, is a second derivative of the function over 2 factorial multiplied by x minus a squared, and we can see a pattern emerge. So each successive term is then found by the following pattern. And we use, let's start already here. So we use this formula. Use the formula. If we try to expand the series at point A. Yeah. So we found the derivatives of the original function, and we use those derivatives in our series when it calls for it. And our derivatives are evaluated at a point A. Okay. Yeah, so after writing these two, we'll focus on this part. Oops. You can see the so maclaurin series is just a special case, arise when we take the Taylor series at the point 0. Okay, so special case. Oops. Special case at point 0. Okay, so if a point is a 0, we get the maclaurin series, and the maclaurin series is a Taylor series at the point 0. Okay. Yep. So yeah, that's all we got for this question. Let's leave a comment there. Okay, so next question is asking us what is the square root of 169 over 225 in fraction. Okay. All right, so to make this easier, we can distribute the square root to the numerator and denominator. Then we take the square root of 169 and 225. Okay, so let's do that. So 169 over 225, and that is our original value. And we want to take the square root of that. And that is the same thing as if we take the square root of the numerator, which is 169, and we take the square root of our denominator, which is 225. Yep. And now we know the 13 times 13 is equal to 169. So therefore, as we take the square root of 169, this is going to be equal to 13. All right, so we have 13 as the numerator, and we know that 15 times 15 is equal to 225. So in other words, if we want to take the square root of 225, that's going to be equal to 15. So we have 15 as our denominator, and that will give us our final answer. Okay. Oops. I'll just add one more step here. So this is also equal to 13 squared. The square root of 13 squared and the root 225 is equal to the square root of 15 squared. And remember that as long as we take the square root of something squared, it's just going to be equal to itself, right? So this is going to be equal to 13, and that's going to be equal to 15. Yep, and which is our answer. I'll just write a couple more perfect squares. Just help you identifying what perfect square are and what their square root are when you come across this type of question in the future. Okay. So we know so 10 times 10, let's start from 10. So it's equal to 100. So square root of 100 is 10. 11 times 11 is equal to 121. And square root of 121 is equal to 11. And we have 12. So 12 times 12 is equal to 144. And the square root of 144 is just equal to 12. And 13, we have 13 about, and let's do 14. So 14 times 14 is equal to 196. And square root of 196 is equal to 14. And we got 15 about, so let's do 16. So 16 times 16 is equal to 256, and the square root of 256 is just equal to 16. And 17 times 17 should be 289. So root 289 is just equal to 17. And 18 times 18 should be 324. And square root of 324 is just equal to 18. Okay, and we got 19. So 19 squared should be 361. And 361, the square root of 361 is just equal to 19. Yep. So I think that's all we go for this question. Okay. Solution. Let's go. Okay. So our next question is asking us how to find the derivative of a given equation. So let's write that down. Find the derivatives of a given equation. Okay. So first, let's write down the general form of the equation for solving any derivative, and that is given by limit as h is approach to 0 of x plus h minus fx over h. Okay, so that is very important, so remember this formula. So let's say we got a we need to derivative the equation fx is equal to x squared plus 2x plus 1. Okay, so let's write step 1. We need to write out the expression for fx plus h So which is fx plus h is equal to x plus h squared plus 2x plus h plus 1. Okay, and we can use this to write out the form, which is f x plus h minus fx over h, and that is from what we have earlier, so those are the same thing. And this is going to be equal to x plus h squared plus 2 times xh plus 1, which is we just copy down what we have above. Let's put that into a bracket, minus x squared plus 2x plus 1 over h. Yep. And then we simplify the equation, which is equal to, first let's get rid of the bracket. So x plus h squared is just equal to x squared plus 2xh plus h squared plus 2x plus 2h plus 1. That's what we have from the first bracket. And minus x squared minus 2x minus 1 over h. Okay. And then we just combine the likely terms, which will give us 2xh plus h squared plus 2h plus 2h over h. And we can take h from the numerator. So that's going to be 2x plus h plus 2. And now you see there is a h at the top and h at the bottom, so we can cancel out the h, which gives us 2x plus h plus 2. Okay. Oh, as the answer for fx plus h minus fx over x. Okay. So now with this simplified expression, we can get the limit as h approaches to 0. So let's write that down. So limit h approach to 0, fx plus h minus fx over h is equal to limit as h approach to 0, 2x plus h plus 2. And as you can see here, we got a plus h, and also h is approach to 0. So in other words, it just becomes to 2x plus 0 plus 2, which gives us 2x plus 2 as our answer. Yep. So therefore, the derivative for what we have earlier, for x squared plus 2x plus 1 is equal to 2x plus 2. Yep. So I think that's all we got for this question. Okay. So let's leave a comment. It's correct. Well done. Alright, so coming up, we have our next question. It's asking us, is pi a rational number? So is pi a rational number? Okay. So let's just recall what pi is. So pi is 3.141 blah 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 blah, and it's not repeated, and it goes to infinity. And okay, so by knowing this, let's recall the definition of rational number. So rational numbers rational number is a number that can be expressed as a ratio or fraction of two integers. So let's write that down. So a ratio or fraction of two integers wherein the denominator cannot be equal to 0. Okay, so if we want to write that as a formula, that there will be p over q, and q cannot be equal to 0. And as you can see, the pi is a number that cannot be expressed as a ratio of two integers, so therefore it is not a rational number. Okay, so let's write that down. So solution is correct. Oops. Yep, so I think those are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you would like to submit your own questions, please read the link in the description. Remember to leave a like and a comment and share this video with your friends. And this has been Angel from our class. Hope to see you soon. Bye.